Hello. Today in our college algebra class, today April 3rd, 2019, in our college algebra class that goes from 9:05 to 10:25, we did quite a bit. And if you're patient with me, I can kind of take you through everything that we did for the most part. So first up, there's this handout. Just let me show you the handout that I'm talking about. So this is a handout that I gave you guys last time, zeros of polynomial functions, and we went through a lot of the skills that you saw in section 3.2 and the beginning of 3.3. So there's synthetic division, there is rewriting polynomials using the division algorithm, there's the remainder theorem here in number 3. There is the method that we use to find zeros, whether or not a number is a zero of a polynomial function, and a lot of other stuff. Okay, but we actually started off this handout by completing number 10, because most of the stuff you had done with Miss Neighbors in 0314. So let's look at number 10. Number 10 says to find all complex zeros of the polynomial function below and list multiple zeros as necessary. List multiple zeros as necessary. All right. So the first step in completing this problem is, well, we actually need a starting point. So we need some zeros to test. And the way we come up with that list of zeros to test is using the rational zeros theorem. So then to use the rational zeros theorem, we say to ourselves, I need a number, if I have a zero rather, that's a fraction in reduced form, I know that the numerator of that number is going to be a factor of 196. Okay, so what are the factors of 196? Well, 1, 2, 4, 7, 14, 28, let's see, 49, okay, and 98, and then finally 196. Okay, so again, just to reiterate, because I think I may have muddled it just a moment ago, but if I have a fraction that's a zero, the top number is a factor of 196, this constant. The bottom number is a factor of the leading coefficient, which is 1. So the bottom number is a factor of 1. So then my list of potential rational zeros, remember what we did? We actually mixed and matched all the ones at the top with all the ones at the bottom. So the list of potential rational zeros is plus or minus 1, plus or minus 2, plus or minus 4, 7, 14, 28, 49, 98, and 196. All over 1. So if I have a rational zero, it's going to be one of these. So then what we have to do then is we have to start testing these, right? And now, because during class we're on a schedule, I didn't want them to start at random, so I just had them start right in here, because the zeros are actually in that little area right there. Okay, and so let's use a 7. Okay, so I want to see whether or not positive 7, since it's in this list, is a 0. Okay, now I have missing terms here. I don't have a cubic term or a linear term, so I need to throw in zeros there for their coefficients. So I have a 1, 0, negative 45, 0, and negative 196. And I perform the synthetic division. So I drop the 1, I multiply and I add, 7, and then I multiply to get a 49, and then I add to get a 4, and then I multiply to get 28, and then I add to get 28, and then I multiply it one last time to get 196. So look at that, 7 is a 0. Okay? So it says to find all complex zeros, and we found one. 7 is a complex number, it's a 0. So now I'm going to take my results and test another. Now keep in mind, what we usually want to do here is once we get a result, we want to try to either factor or use the quadratic formula or use some other method. But we can't do that because our initial problem was a 4th degree. That means this first result here is a cubic. So then I'm going to try one more time to find another one, and if I find another one, the result then is going to be a quadratic, and I'm just going to use the quadratic formula. Okay, so let's see, how about I use a negative 7? So then I have 1, negative 7, a 0, a 0, and a 4, and a negative 28. So yeah, it looks like negative 7 is also a 0. So this is 1x squared plus 0x plus 4. Since it's a quadratic, I want to set this equal to 0 to find my remaining two zeros. Now there are multiple ways to solve this equation. The easiest way actually will be to subtract 4 from both sides and take the square root of both sides. And if you do that, you end up with plus or minus 2i. But just to stay consistent with everything that we've been doing, we'll use the quadratic formula. So remember, the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. b is a 0. Right, so I'm just filling in 0 everywhere I see a B. A is 1 and C is 4. And that's all over 2. So then this is plus or minus the square root of 16. Negative 16 actually, all over 2. And the square root of negative 16 is 4i. So plus or minus 4i all over 2. And like I said just a moment ago, your two remaining zeros are plus or minus 2i. Okay? So there we have it. So that's the first example we did at the very beginning of class. Keep watching to see the remaining videos or the remaining examples.